morning. I'm sure you're all excited after yesterday's sessions talking about the Meta Quest 3. Ready to dive into some more details? I said, are you ready to dive into some more details? Great. My name is A.R. Schleicher, and I'm a developer relations engineer here at Meta. I'm proud to say I'm an original Kickstarter backer, and I've been to every single Connect. At that first Connect, I never imagined that I'd be the one up on stage presenting the details of the latest headset. So what do? Basically, I help developers solve whatever problems or challenges they might be facing with a focus on the latest hardware. This year, it's the Meta Quest 3. I'm excited today to walk you through a more detailed overview of the Meta Quest 3 headset and Touch Plus controllers, and what you should keep in mind as you're developing for them. So, what is Quest 3? Quest 3 is our next generation headset that will be available in 2 weeks with a number of substantial upgrades over Quest 2. So, what's changed? Well, there's 3 main areas to look at when it comes to the Quest 3. Headset improvements. By this, I mean things like the increased display resolution or the increases in CPU and GPU processing power. As for mixed reality, the dual-color cameras resulting in high-quality color pass-through and new features like occlusion, scene mesh, depth APIs, and color lookup tables. Touch Plus controllers. Here, the highlights are the ringless design, VCM haptics, and the 2-stage trigger. So let's get started digging into these details. One of the biggest upgrades for existing VR developers has to be in terms of compute. The all-new Qualcomm Snapdragon XR2 Gen 2 platform represents an increase of over 33% in CPU performance compared to the Quest 2's XR2 Gen 1 platform. In terms of cores, there's only 6 CPU cores available compared to the Quest 2's 8 cores. Hold on, isn't that a downgrade? Quite simply, no. On Quest 2, 5 of the 8 cores were reserved for the operating system to use. On Quest 3, there's only 3 cores reserved for the operating system, meaning that in both cases, there's 3 cores available for developers. However, this does mean that some of your performance analysis tooling may need to change. On Quest 2, the cores available to applications are CPU 4 through 6. On Quest 3, this changes to CPU 3 to 5. But that's just one side of the coin. On the flip side, with the GPU, things are even better. The upgrade from the Adreno 650 of Quest 2 to the Adreno 740 of Quest 3 represents a significant boost, more than 200% the GPU processing power. In fact, we're revising some of our prior guidance. On MetaQuest 2 and earlier devices, we've had to warn developers away from deferred rendering. The GPU power just wasn't there. However, while still not for all applications, our early tests on Quest 3 have shown that this now can be a path worth evaluating and considering. While we're on the topic of graphics, let's go into some details of the optical stack. Quest 3 contains a 2064 by 2208 display for each eye, a significant boost over the 1832 by 1920 of the Quest 2. Just like the Quest Pro, these displays are rotated at an angle, making it significantly harder to pick out individual pixels, especially when you're looking at both displays at the same time. The default eye buffer size also received a boost, going from 1440 by 1584 on Quest 2 to 1680 by 1760 on Quest 3. Why not closer to the native resolution of the panel? Considering the distortion that takes place to make the image display correctly to users, we found this to be the best balance of resolution and performance. If you've got a particularly demanding application, remember that our VRCs allow you to adjust this render scale to as low as 85% of these values, while if you have extra GPU available, raising this higher can make your app look even better. The new dynamic resolution functionality available in V56 and later versions of the SDK allow you to automatically scale up and down based on application performance. What about the field of view? Quest 2's horizontal field of view depends on which IAD setting you're using, but the middle setting is 96 degrees horizontal. On Quest 3, we've increased this to 110 degrees horizontal, almost a 15% increase, and this is available for all users, regardless of how you've adjusted the IAD or lens position. Along these lines, it's worth calling out the smooth IAD adjustment of Quest 3. While those of you with Quest Pros may already be used to it, Quest 3 represents a return to a continuous IAD adjustment wheel, rather than the 3 set positions that are present on Quest 2. Another related comfort setting is how the glasses spacer works on Quest 3. Like many of you probably do, I need to keep my glasses on while I'm developing and switching between the editor and headset. Unlike Quest 2, where the glasses spacer was this odd plastic piece you'd remove the facial interface to install if you needed it, the ability to add more space for glasses on Quest 3 is built into the facial interface. Simply press the buttons located on each side of the facial interface, and then move the outer portion of the facial interface in or out, choosing between 4 different settings based on the size of your glasses. Now, let's talk about the weight of the Quest 3. The Quest 2 weighed 503 grams on its own, or 512 grams if you added in the glasses spacer. In comparison, the Quest 3, with its built-in glasses spacer, is 515 grams. In other words, it's about the same weight. However, with the changes to the form factor bringing everything much closer to your face, it's significantly more comfortable to move around and turn your head with a Quest 3. Speaking of that form factor, how did we improve it so much from Quest 2? This is largely thanks to the pancake lenses, which you may be familiar with from the Quest Pro. As we no longer need to have as much distance between the lens and the screen, we can bring all those components behind the screen, like the processor and the battery, in closer to your face. Of course, the upgrade from Fresnel to pancake lenses comes with a significant improvement in image clarity as well, removing the God ray artifacts that were so common with the older lenses. Let's zoom out for a moment and talk about RAM, storage, and battery life. Quest 3 contains 8 gigabytes of RAM. That's a 33% improvement over Quest 2. We expect most developers will use that for more detailed, higher resolution textures. However, the choice is, of course, up to the application developer, and there's plenty of other ways you might choose to use that memory. As for storage, there are 2 options available: a $499 model with 128 gigabytes of storage, and a $649 model with 512 gigabytes of storage. As games get larger and more complex, like with higher resolution textures, they'll consume more space. The 512 gigabyte model allows you to have more games and applications installed on your headset at once, making it easy to switch between them without having to uninstall one in order to have enough room to install and play another. Regarding battery life, Quest 3 does require more power than Quest 2, but has a larger battery to deliver it. While gaming, our expected battery life remains about the same, at about 2.4 hours of gaming use, or 2.9 hours of media use. However, when utilizing the new mixed reality features such as color pass-through and the depth API, battery life will be lower. The trade-off, though, leads to some amazing results. What sort of results? Well, I'll take a moment to talk about my favorite example, piano vision. I took piano lessons while growing up, and while I can read sheet music, Piano Vision's approach to teaching you to play the piano is really something else. While it has modes that just use hand tracking, connecting a MIDI keyboard is where it really shines. It's just an outstanding experience that I encourage you all to try. This sort of new use case, teaching piano lessons, is the sort of thing I'm really looking forward to seeing in the years to come. What sort of amazing MR applications will you come up with? I'm excited to find out. So, what new MR capabilities does Quest 3 bring to developers? Well, first off, Quest 3 contains dual 4-megapixel color cameras. This is a big upgrade compared to Quest Pro's single 1-megapixel color camera, eliminating the color bleed artifacts you'd see in Quest Pro's color pass-through. Of course, it's an even bigger upgrade over Quest 2's black and white 640 by 480 cameras. As a result, the quality of color pass-through is dramatically better. You really need to experience it yourself. The way I describe it is this. This is the first time I've really felt comfortable looking at and actively using a cell phone from within a headset. So, what's one of the first times you're likely to use color pass-through? It's when you do space setup to create a scene mesh. As you may have noticed, we've replaced the old manual room setup of the past with a new space setup process. Simply walk and look around the room, and the Quest 3 will build up a representation of the environment around you. Applications can use this data, like they did with the old room setup data to, say, put items on a table. But when you set up your room with space setup, this also creates a scene mesh. The Mesh API enables developers to create fast collisions for physics and navigation experiences in MR. It's a full 3D mesh of the world around you that multiple applications can use to provide more precise interactions with the world than have ever been possible before. Next up, occlusion. Occlusion is another new feature that's available for developers and allows them to create a situation where the real world blocks or occludes a virtual object that the application is rendering. The easiest example to think of here is a character sitting down on a chair at a table. The table occludes their lower body from appearing, and all you see rendered virtually is their top half. Now, this one isn't quite done yet. While you could use the scene mesh for static occlusion, it's not recommended. You'll need the depth API to do dynamic occlusion, and it's only available as an experimental API in v57. Depth API gives you access to a real-time depth map, allowing you to occlude objects based on that dynamic information. Another new API I expect to see used in some creative ways is color lookup tables, or LUTs. Basically, this allows you to specify a mapping from one color to another for pass-through purposes. The simplest example? Imagine a scenario where you map all the green to red, and now all the plants around you in reality are red instead of green. Or take a look at the example pictured here. This room normally has white walls, and there's an orange pillow at the bottom. You can use color LUTs to turn the whole room orange, or you can be more selective and just use it to change white or gray areas to shades of green, while leaving the orange pillow alone, unchanged. Now, I'd like to set some expectations regarding compute and battery life when using the mixed reality functionality. You may have heard of this idea before. There ain't no such thing as a free lunch. Nowhere is this more true than when it comes to the mixed reality functionality on the Quest 3. The hardware features take up more battery power to run, and this eats up more of the thermal budget. As such, you should be aware of the constraints that exist for MR applications. An MR application that is making full use of the device may see battery life around an hour and a half instead of 2+ hours. In addition, CPU and GPU will be limited to lower frequencies and power levels to make sure the device can continue to function normally while these applications run without overheating or experiencing a brownout. Trust me, there's nothing I'd like more than to provide developers with the most CPU and GPU possible. We've got extensive monitoring in place to see if additional headroom exists. And if it does, it's something we'll consider in future operating system updates, similar to the recent changes we made to boost Quest 2. If this taste of MR has got you excited, don't worry. There's more coming up in the next session with Jay Golaguri and Britta Hummel. Now, let's talk about the all-new MetaQuest Touch Plus controllers that come with the Quest 3. The first thing you'll notice is that there's no rings, just like the Touch Pro controllers. This dramatically improves situations where your two hands are close together. No more ring collisions. However, the next thing you'll notice is that there's also no cameras. What sorcery is this? Well, we've put the LEDs of the controller ring into the faceplate, the black part of the controller, as well as one LED in the base of the controller, just beyond where your pinky and ring finger hold the controller. This, combined with some good use of the IMU data, along with some smart AI models, allows us to relatively accurately track the controllers without the tracking ring in a large majority of cases. One of the big differences you'll notice is when it comes to the tracking camera placement on Quest 3. Quest 2 had 4 cameras, a pair at the upper corners, and then a pair on the bottom towards the center on each side. Quest 3 also has 4 tracking cameras, but this time it's a pair at the lower corners and a pair in the center, roughly where your eyes are in a front view. This means the tracking volume between the two headsets is different. What do I mean by different? Well, larger for one thing. When comparing all the space tracked by both headsets, Quest 3 can view 91.79% of the space, while Quest 2 can only view 89.69% of the space. In other words, Quest 3 can see controllers in more of the space around you. Let's take a look at some views of the space around the user. From the top, this might look a bit concerning. Take a look at these images, comparing the theoretical tracking volumes for controllers. Quest 2 covers the area above you quite well, while Quest 3 leaves that area uncovered by any camera. However, it is worth noting that the area behind the user, where the cameras can't see, is actually smaller now than it was on Quest 2. The impact of this is actually more readily visible on a front view comparison. Now, these two images are the results of our tests to verify the difference between the areas where the controllers can be seen on Quest 2 and Quest 3. You'll notice that Quest 2 has a large area above the head where controller tracking is significantly better, and it also has a small area under the chin where tracking is better. However, the Quest 3 image shows bigger improvements. There's a large volume of space to each side of the user where controllers couldn't be seen before, but now can be seen. There's even a location that used to be a blind spot in close to the headset above the head that now gets some coverage. So, what about that area above the head? It's generally not an issue. For short periods of time, IMU data combined with our improved AI models are able to accurately position the controllers. And longer periods of time generally don't happen very often or very long. It's tiring for users to hold their controllers above their head for long periods of time. In short, the controller tracking on Quest 2 is better than Quest 3. It both covers a larger area than Quest 2, and it does a better job covering the areas you're most likely to have your controllers in. What if you have Touch Pro controllers? The Touch Pro controllers, announced at last year's Connect conference, also work with Quest 3 as well. You'll need to set up your Quest 3 headset using the included controllers, but once you've done that, you can unpair the Touch Plus controllers and pair Touch Pro controllers. So, for any applications that perform better with the unlimited tracking volume, or applications that want to make use of any of Touch Pro's other unique features, like the stylus, thumb pressure, or the thumb or trigger haptics, there's a solution available on Quest 3 in the form of Touch Pro. Speaking of haptics, well, the haptics on the Touch Plus controller are certainly improved, but not quite to the level of Touch Pro controllers. The Touch Plus controllers do not contain the trigger or thumb LRAs that the Touch Pro controllers do have, but they do each contain a single VCM haptics device in their base. This VCM allows for control over both the frequency and amplitude of the haptic effect. While it's quite similar to the VCM in the Touch Pro controllers, it isn't exactly the same. That doesn't mean you need to design your haptic effects twice, though. For the best developer experience, we recommend using Meta Haptic Studio. This application, released earlier this year, allows developers to create, audition, and integrate haptics just once, and then have them work appropriately across our full line of headsets. It's available for download now from our developer website and supports both Unity and Unreal. There's one more little secret hiding in these controllers. We've changed the index trigger on the Touch Plus controllers so that it is a two-stage trigger. What's that mean? Think of the current index trigger behavior as the first stage. Once you've fully pulled the trigger, you can now apply additional force to the trigger, and that will be measured via a second value, index trigger force. An afterburner for an extra burst of acceleration, an extra powerful boosted shot, or perhaps something requiring a bit of skill, where the user can get a little extra power, but pressing too hard will result in some sort of burnout. We're eager to see what designs developers come up with to make use of this functionality. So, how do I make use of all the new functionality? As always, it comes down to getting the latest version of our SDKs. The public v56 SDK contains some Quest 3 support, including Touch Plus controller models in Unity, and is a great place to start, while the v57 SDK, with even more, should be available within the next couple days. So, here's the point I want to leave you with. There's never been a better time to start developing for VR and MR. Quest 3's increased CPU and GPU power, along with more memory, allows you to create a more complex experience at a higher fidelity than ever before. greatly improved color pass-through, the Depth API, and color LUTs to power the most immersive mixed reality experiences. And, of course, the new ringless Touch Plus controller with improved haptics and the two-stage trigger. With that, you've got all the tools you need to develop for VR and MR, and Quest 3 is the device to develop for. I can't wait to see what you make.
Do you want to learn how to elevate your app's experiences with Presence Platform? Then you are in the right place. Jay Galuguri.
Good morning. Mixed reality enables a new class of experiences that let you convincingly place and interact with digital content in the real world. My name is Jay Golaguri, and as a product manager for mixed reality, let me show you how to unlock this magic in your apps. Last year at MetaConnect, we announced several mixed reality capabilities in the Presence platform. Let's take a brief look at some of the apps that you have built to date. Wow, those are some amazing apps that let you engage in a round of body combat or challenge yourself to navigate a laser maze right in your living room. Mixed reality, when done well, can improve comfort, safety, and immersion for your users. And pass-through can reduce isolation or friction when onboarding new users. Mixed reality also has the potential to increase your user engagement significantly. For example, Trip incorporated pass-through and boosted their 7-day average daily active users by over 30%. All of these applications are powered by Presence Platform's mixed reality capabilities. Pass-through, scene, and anchors. You can use them natively in Unity, Unreal, or WebXR. First, let's talk about pass-through. Pass-through is amazing on MetaQuest 3, with 10x more pixels and a new AI-powered depth engine that takes full advantage of the hardware. All your mixed reality apps automatically benefit from this new pass-through. In fact, pass-through is so natural and realistic that we have redesigned the MetaQuest 3's new user experience, as well as the default home environment to be in pass-through. To take this even further, later this year, we're going to let users seamlessly transition from pass-through in home to your MR app, removing all jarring black loading screens forever. To get your apps ready, there are just two simple steps. First, use an instant runtime splash screen in your app. And second, just enable pass-through in your app at startup, and you're all set. Next, let's talk about scene. What makes mixed reality truly magical is when the experience adapts to your space. Scene API on MetaQuest 3 leverages a brand new space setup. With space setup, as the user looks around, we automatically create a representation of their space, such as outlines of walls and furniture, for your apps to use. And also starting today, users have the privacy controls to choose which apps have access to this data. To enable your apps to leverage all of these capabilities of the MetaQuest 3 and the space setup, we are introducing Mesh API. Mesh API enables your apps to do things like have a game character navigate in a real space, or maybe to convincingly place virtual content that could transform, say, your living room into a forest campfire. How cool is that? Lastly, mixed reality enables freedom of movement. Users naturally desire to move seamlessly and expect their experiences to adapt to this space. Starting later this year, we will also allow users to set up multiple rooms with space setup. So your apps can leverage all of these rooms and have your users move freely in them. Now, what if we had the tools to making developing for mixed reality easier and faster? To tell us more about this, please welcome Britta Hummel.
Jay. Developing for mixed reality just became easier, faster, and more immersive. Let's start with easier. If you're new to mixed reality development, we're now making it easy to get you started. We're announcing building blocks for Unity. With building blocks, you can simply drag and drop background pass-through, camera rigs, room models, grabbable items, and so much more right into your Unity scene. It's that simple. Just drag and drop. Building blocks will be available in early October. And earlier this year, we also introduced the Unity project setup tool to easily configure a performant MR project. Now, if you already have a VR app, here's something you can try in less than a day. Use building blocks and try replacing your app's VR background with a pass-through background, if it's appropriate. This way, users who prefer staying grounded in their real environment can do so. Now, if you're already building for MR, we have 4 great updates to make development for you faster and better. Number 1, in partnership with Unity, we recently announced AR Foundation support for MetaQuest. With AR Foundation, you build MR applications once and release them on any ecosystem of your choice, not just Meta's. And we're shipping Presence Platform features on Unity and Unreal simultaneously. This is your engine, your ecosystem, your choice. 2, we're announcing the Depth API. Depth API provides you with real-time, per-eye, per-frame depth estimates of the environment. For example, with Depth API, we can render our virtual friend Api here behind that real chair. And that's called dynamic occlusions, and you can do it now in your apps. And if you're a graphics pro, you can go a lot further. We've designed the API so that you can bring your own depth-based effects. You can render fog. Isn't that cool? Or you use depth information for gameplay, like with this flashlight here. We're super excited about this. You can start experimenting with Depth API on MetaQuest 3 starting today. And 3, you told us developing for scene can be challenging. Where should you place content if you don't know the user space? And how will the app look like in different spaces? Well, we listened. And today, we are announcing Mixed Reality Utility Kit. With the MR Utility Kit, you'll get spatial queries, which will make it easier to ensure your content shows up at the right place in any user space. And it's got helpful utilities for working with procedural meshes and textures, as well as dozens of pre-captured spaces. So you can test how your app looks in your user spaces, not just your own office. And all of this without donning the headset. And there is so much more. Mixed Reality Utility Kit will be available for Unity and Unreal later this year. And 4, you can now develop for MetaQuest without needing a physical device. We're releasing the brand new MetaXR simulator. It provides you with synthetic environments so you can quickly build and test mixed reality applications on your PC or Mac. Stay tuned for more on a MetaXR simulator in the next session. So let's recap. This is what Jay and I want you to walk away with today. We're making it easier and faster to build more immersive MR experiences today. Building blocks and project setup tool make it easier to get you started. Mixed Reality Utility Kit and MetaXR Simulator make your development cycles faster. And the new Depth API and Mesh API make MR development more immersive. And lastly, Quest support for AR Foundation simplifies building those MR apps across platforms. On MetaQuest 3, built from the ground up with and for mixed reality, there is no better time than today to get started building those mixed reality experiences. So check out our Presence Platform website at the QR code today, where you can read up on everything Jay and I just talked about. And so also check out our latest open source reference app, Fanto, which will show you in code how to use some of our newest capabilities. Thank you.
If you are looking to delight your users and build a successful business on MetaQuest, this is the session for you. Please give a warm welcome to Jisoo Shin.
Hi, I'm Jisoo, and as a software engineer on the developer success team, I recently had the opportunity to visit one of your studios. It was awesome to see your day-to-day development process and what you're building, despite the challenges of having to keep up with the latest hardware and SDKs, and even building for multiple platforms at the same time. And so you shared your pain points with all of the tools that you have to use, some tools that you built from scratch, and even the manual processes, which all take away from your core development time. This really inspired us to take a closer look at some of our most popular tools that you're using and to make them better. And so today, I'm excited to walk you through some of our most popular tools, like the MetaQuest Developer Hub and the MetaXR Simulator, share some updates that we've made to them, and also introduce some new and upcoming features that we believe will help you build and launch the highest quality version of your app. I'll start by giving a walkthrough of the MetaQuest Developer Hub, or MQDH, which is a desktop companion application to the MetaQuest and a centralized place for your development. In the Device Manager, you'll see a UI for easily managing your devices and your device settings, as well as a UI for some common ADB commands, like disabling the Guardian and the proximity sensor. There are also media capture tools like screenshotting, video recording, and casting to help you easily share your in-app experience. And as a software engineer who frequently uses media capture tools, I know how useful they are. So that's why I'm super excited to share that the team has been making huge improvements in this area. This next video I'm about to play was captured using our new wired casting experience that you'll soon be able to use later this year, which streams over USB in widescreen cinematic 4K. It captures an additional 30 degrees horizontally without cropping, so that you can share and stream exactly what you're seeing in your headset. And by the way, some of the videos captured in this presentation, like this one, were captured using this new feature. So I'm super excited for you to be able to use it on your own apps. You can also enable the OVR metrics tool to easily select metrics that you want overlaid in your headset to track real-time performance stats, like app GPU time and CPU and GPU usage. And for even more real-time tools, you can go to the performance analyzer to set flags on metric thresholds to easily spot issues and bottlenecks. In the app distribution tab, you can upload your builds to your release channels to distribute them to your users. And another feature that may not be as visible is our drag and drop feature. So you can drag and drop an APK anywhere and choose to either upload it or install it directly onto your headset. And in the Downloads tab, you'll find additional tools, SDKs, and my favorite, code samples, which we're constantly updating so that you know how to build using our latest new features. And some of these code sample showcase apps we'll demo in this presentation. Okay, now I'd like to introduce some new and upcoming release channels and playtesting features. Building a high-quality app is hard, and it's time-consuming. So we know how important it is for you to get early feedback on your apps. You'll soon be able to use release channel URLs, which were designed to make it frictionless for you to easily share and distribute your early builds. From your developer dashboard, you can create new or edit your existing release channels to enable URL invites. And then share this link however you wish, whether it be sharing it internally through work or externally through Discord. And then when users and potential beta testers land on this page, they'll see your app information, as well as the ability to join or request to join your channel. Once you approve these requests, these users will be able to see your early build in their app library, where they can install and start playtesting. Now that these users have access to your early build, it used to be up to you to decide how you wanted to collect and manage playtesting feedback. You shared your struggles in this area, sometimes distributing your early builds through Discord and collecting feedback manually, not knowing if feedback is even relevant because maybe your testers were testing the wrong app version, or maybe their headset just needs to install the latest firmware update. I'm excited to share that you'll soon be able to use a new in-app playtesting feature later this year. Your app's testers will soon be able to submit feedback directly in the headset, which is less disruptive to their headset experience because they don't need to take off their headset to write down feedback and then put it back on to jump back into the app. But it also provides you with more high-quality contextual feedback. Let's go back and demo the video. While playing your early build, your testers can trigger the pause menu, which will bring up a new in-app feedback form. Here, they can add their feedback with the option of using speech-to-text, and also attach media from their playtesting session, like a screenshot or a screen recording. And once they submit this, you'll be able to see it in your developer dashboard. Now you can easily address only the feedback that's important to you by easily filtering on things like device type and app version. And you'll see more contextual information with the media that they attach, as well as the specifics of the headset that they're using. So no more having to manually collect this information or have to guess at what part of the app that the feedback is referring to. Now, I'd like to highlight some recent improvements that we've made to address some of your most common developer pain points around managing your live builds. We've made improvements to scheduled releases, which used to be a cumbersome process that can now be scheduled in one click. And we all know that app updates can take a long time, especially for large multiplayer apps. So we've added the option of securely pre-downloading the build onto your users' headsets before your scheduled launch day. So when your app launches, your users will be able to completely skip the download phase. No matter how much your build has been tested, it's still hard to predict whether your users are going to experience issues on your launch day. So if there is a problem, rather than having to immediately fix code, upload a new build, QA it, and then push it out to fix your users, you can simply use the app rollback feature to instantly revert the problem build by selecting any of the builds that you had uploaded previously. I know this was a huge developer pain point, so I hope that this app rollback feature provides you the flexibility and peace of mind that you need on your launch day. Although this is only the tip of the iceberg of all of the improvements that we've been making, we hear you, and we want you to keep providing feedback on these tools so we can help you focus on the things that matter most, like your core app. Now, I'd like to hand it off to my colleague, Xiang Wei, tech lead on the developer technology team, to dive into some tools you can use in your core app development.
Hi, everyone. Before joining Meta, I spent almost 20 years building games for many different platforms. With all my experience, I can tell you, building XR apps is not easy. Switching between your headset and the computer is cumbersome. You'll often find yourself debugging system issues instead of app issues. Waiting several minutes before checking a simple logic change on headset is not fun too. That's why we created Meta XR Simulator. There are many ways to simulate an XR headset, and we choose the hard way for good reasons. Meta XR Simulator is a fully featured open XR runtime that runs on your computer. You can run any open XR apps on top of that, including game engines. It simulates our Meta Quest and Rift headsets with a lot of awesome features to help your development. Here is the debug window of Meta XR Sim. It helps you to set up the simulation and visualize what your application does from the angle of open XR runtime. You can choose the device that you want to simulate. Switch between left, right, or both eyes. Find all the details about the composition layers that your app submitted. Check the current status of your headset and the controllers. Find the key bindings so you don't need to remember them. And finally, record your inputs and replay them to speed up testing. Although debug window is valuable to your day-to-day development, it's not an essential part of the simulator. The simulator can also work under batch mode and supports your OpenXR application silently if you want to set up your own automated testing. Meta XR Sim allows you to easily control your XR application through keyboard and mouse, or an optional Xbox game controller. Let's take a look at this short demo. You can simulate your headset motion and control input with your keyboard and mouse, which you have every day. Or you can do that with an Xbox game controller. As you can see, it allows you to easily iterate your app's interaction without picking up the touch controller every time. Meta Quest 3 provides an extraordinary mixed reality experience. But how would you build and test apps efficiently? Our mixed reality simulation can help. Powered by our synthetic environment server, Meta XR Sim can allow you to easily test your app and a simulated environment. All major mixed reality features, including pass-through, anchor, and scene APIs, are simulated. The room you are seeing right now is a simulation of the pass-through. The scening of that is generated by the mixed reality game. All game objects are interacting with the environment as if you are testing the app on your headset. Mixed reality is new and exciting. It will be easy for you to explore new opportunities with Meta XR Sim. In my entire game development career, multi-client testing was the hardest part. The situation is no better in XR. No one can test their app running on two headsets at the same time. With the simulator, you can run multiple apps on your computer. Each of them has their own open XR runtime. All the Meta XR instances can share the same synthetic environment, which makes it super easy for you to check how your application does under a multiplayer setting. Here is another demo I want to share with you. Here we have a game room at one of our Meta offices captured using Nerve technology. After importing it to Meta XR Sim, you have a beautiful and photorealistic environment for your mixed reality app. Now you may ask, can I create my own synthetic environment? The answer is soon. We are planning to provide the tools for you to bring your own room to mixed reality. Meta XR Simulator is available today and supports both Unity and Unreal. If you are, thanks. If you are using another game engine, or one of those hardcore engineers who write native open XR apps, Meta XR Sim is also for you. We hope every one of you can use Meta XR Simulator in your development. Simulation is awesome, but you still need to optimize your app on a physical headset. We offer a comprehensive set of tools to help you do that. Here are a few tools that you will find handy. OVR Metrics tool provides a real-time on-screen graph overlay to show the performance data. OVR GPU Profiler can give you a lot of details about how your Quest GPU performs. Performance Analyzer is the one-stop solution you can find inside MQDH. Meta Quest scriptable testing allows you to set up your own automation workflow very easily. On top of them, we also help you to get the full support of some awesome third-party profiling tools, including RenderDoc, Profeto, and simple perf. We optimize them for MetaQuest platform to make sure they will work greatly for you. Besides all the great development tools, you could also enjoy our showcases, where you can find inspiration about how to use our cool new features to make your app even better. Here are the 3 showcases that we released early this year. They are all open sourced on GitHub and playable on AppLab. You should check them out to grab some of the best practices or even content that you want to use inside your app. We are going to release a new showcase in the next few weeks. It takes mixed reality even further and makes your home an escape room. It's very cool, right? You can find many other showcases in MQDH, GitHub, and AppLab. Check them out today and start building your next killer app. We succeed when you succeed, and we want to set you up for success. That's why it was so critical for us to understand your pain points and build tools and workflows that would actually make your life easier. We are confident that all the tools which Jisoo and I presented today will provide a huge help to your success. Continue to tell us what you need so we can help you develop the best apps ever. Thank you very much.
Model Llama.